This is chapter 6, problem number 5. The lucky number for this problem is 5. What is the minimum work needed to push a 950 kilogram car 710 meters up along a 9-degree incline? Okay, ignore the friction. What's going on here? All right, so now you have an incline. This is 9 degree. Ignore the friction. That means it's frictionless. Okay, for example, you push up the hill of an ice. Okay, so ice hill, you push it up. Okay, so let's see. Let's put this down. What would this object face? If you draw a free body diagram, it's going to, well, if it doesn't move, for example, okay, and if it stays on ice, that means you have gravity, you have a normal force. If you only have these two forces, then it's going to, the resultant force will be in this direction. So somebody must be pushing it in this way. Otherwise, if this is ice and it's in an inclined plane, that means it must go going down. Okay, and this force is equal to this inclined force, theta equal 90 degrees, is equal to m times a, where a, if it inclined like this, is equal to g times sine of theta. Okay, please write down this formula. Let's see whether this formula works. Okay, if theta is 0 degree, if sine of 0 is equal to 0, so when theta equal to 0, a is equal to 0. Okay, that means when it's flat on horizontal, there's no acceleration in this way or this way, it just stays there. Let's say if theta is equal to 90, okay, that means you have something like this without, okay, 90 is like this. This is your wall, this is your plane, okay? So this one is going to just drop, okay? It will be, acceleration will be gravitational acceleration, that is equal to 9.8 meters per second squared, okay? A is equal to G, so this formula actually works. Okay, so the inclined force is equal to m times a, that is equal to m times a is g times sine theta, g sine theta. That's your force over here. So I'm going to write that again. So F inclined, that is equal to m times g times sine theta. Okay, m is 950 kilogram, g is 9.8, and times sine of 9 degree. Okay, by the way, you have to know how to use your scientific calculator to do sine of an angle. So 950 times 9.8 times sine of 9 degree, that is going to give me 1456 Newton. Okay, let me double check. 950 times 9.8 times sine of 9 degree. All right. Work, well, the master formula is equal to force times distance. Okay, force, we just calculated 1456. Distance is given times 710 meter Newton. So that will be equal to, wow, the number is big. Okay, the number is very big. So I'm going to divide that by 1,000 and it will be 1034 kilojoule. Okay, the lucky number for this problem is 5.